So thank you everyone for attending today's webinar. This is the first webinar in 2026, so we're very excited to have you. And in this webinar, we actually have a lot of new things that we've been working on the back end. So we're very excited to show you what we've been working on. So we're going to be talking about the new CLI tool, OpenFrame and how to use it, and all the updates to OpenFrame, and a new production aggregation model to take your chips from prototyping all to production. So I just wanted to recap quickly about Chip Ignite and the program and how it works. So Chip Ignite is aimed to be a fast and effective way to prototype your custom ASIC with a path to production, which we're going to be covering by the end of the webinar. And basically how it works is that we have multiple SoC platforms. We have Caravelle, Caravan, and OpenFrame. They support different kinds of designs, so we're gonna be focusing on OpenFrame today. And they're standard templates, so that's what you use when you go through the Chip Ignite program. It supports 10 millimeters squared of area and 15 millimeters squared of area. And basically with the 14,950 per project price tag, you get 100 QFN package chips plus a evaluation board so that you can start testing your design right away. Also, everything we have is open source, so the tools, the PDK, the templates themselves, everything's open source. So once you start the project, you actually don't have to do any NDAs or licensing agreement or anything like that. You can just download and start the project right away. And we do provide an IP library. So we're actually gonna talk about that later, also in the webinar. Our new marketplace, which has both commercial and open source IPs. So you're gonna have access to open source IPs that are free to use, and you can use them right away in your design. And there's also commercial IP that has been like taped out on production chips and has been fully silicon validated in millions of chips. So yeah, if you're interested in that, please go ahead and look at the marketplace on our website. So just briefly about how it works. So basically, when you start a project, you actually only get a free an empty space, and that empty space is where you basically put your design, and you hook it up to the pins. So there are pins for the GPIOs and pins that connect to the RISC-V processor if you're using Caravelle or Caravan. And that's what you submit to us through the SFTP server. And then what happens on our end is that we take that design and we integrate it into the template that you chose. And we run some things like fill insertion, and then we run some checks like DRC and density checks to make sure that your design is manufacturing ready. And once that is done, you get back a report and the full GDS and everything to inspect. And once you confirm that everything looks good, we tape it out and send it to the foundry. So let's dive deep into OpenFrame because that's the topic of today. So OpenFrame is basically an empty template. So it doesn't have a RISC-V processor. We replaced the RISC-V processor with empty space, so you get more space, 15 millimeters squared of area, and 44 programmable GPIOs, or configurable in this case. When to actually use OpenFrame. So you use OpenFrame definitely if you're comfortable with ASIC design, because it is a bit more complex than Caravelle. So Caravelle is very user-friendly for someone that is not very comfortable with ASIC, or it's the first time to tape out. And if you need more space or more GPIOs. And also, we've seen cases where you would want to create your own processor, and you want to take the whole space. So that's another opportunity for you to use OpenFrame. So we're actually making OpenFrame easier to use, because we've uh, lately, until now, you had to actually understand how the GPIOs work and configure them in your design, which is, we all know that it's a bit complex. So we created a new soft IP. It's called CF GPIO config. This IP is made specifically for configuring the OpenFrame GPIOs. So you basically choose a mode. So we have 6 modes. We have analog, we have input pull down and input pull up, and we have output and bidirectional. So you instantiate that IP inside your actual design. So you instantiate it once per IO. And it basically gives you the same interface as Caravelle, which is output, input, output enable, and analog. So you actually here, like it's shown here, you instantiate the IP and you choose the mode, so one of these modes. And then it will this is your interface, output or input or output enable, and then you connect the relevant GPIO pins from OpenFrame. So these are all the pins that are provided already in OpenFrame. So you just connect them to that IP and connect your design to the interface for that IP. So this will handle all the configuration, so you don't have to actually worry about how to configure the GPIOs anymore. And you should instantiate it once per IP. And then another thing that we want to share with you is the new CLI tool. So if you've ever used our flow, you would know that we have been using makefiles. But we're calling it legacy now because we actually developed a new CLI tool that's based on Python, so it's much more reliable, and the logging is much better. So and we kept the same flow as what we used to have in the makefile, so it's not an entirely new flow, and even like the commands themselves are similar to what we had in the makefile flow. So you still start with cloning your repo. There is an extra step where you initialize the project, and that basically tells the tool what kind of template you're using, and if you want to give it another different name. And then you do the same setup. It's called now CF setup, which basically is going to set up your environment and install all the dependencies so that you can start designing right away. And then we actually moved to a GUI based GPIO configuration for Caravelle and Caravan. So through the command CF GPIO config, you'll get a GUI where you can actually just configure the GPIOs with a click of a button. We used to have them in a configuration file in Verilog, but now we have them in a GUI, which is much easier to configure. And then it's gonna be the same for verification, for hardening using OpenLane, for running pre-check. It's all the same. And of course, we're doing the tape out submission through SFTP using the same CLI tool. So it's all under the same umbrella. And now I would like to show you a full demo on how to actually start a project in OpenFrame. So we're gonna start with a template. So we're gonna create a new repo. Let's call it OpenFrame webinar demo. And we can click here and it would create the repo under our own account. So once that's done, you can clone it under your, you can click here and clone it on your machine. I already did that. So we're gonna start from here. After cloning, we're gonna do an initialization. So we're gonna do cf init. I'm gonna change the name. I'm gonna call it demo. It already detects the name and detects the type. So if you press enter like here, it's gonna autofill it. And then we are going to set up the environment. So we're gonna do cf setup. So here, as you can see, it installed all the dependencies. So Caravelle, OpenLane, the PDK, the timing scripts, CocoDB, and precheck. So everything's set up on your environment so that you can start working right away. And then I am going to install the IP that we were just talking about. So I'm just going to list all the IPs here. And it is called, it's actually this one. So cf gpio config. So this is going to install the IP from IPM. And by the way, if you want more details about IPM, we do have a video on YouTube and documentation on our knowledge base to how to use IPM and how to install the IPs from it. So now we can actually take a look at the code. I have here a demo example. So basically in the OpenFrame wrapper, I only instantiated the example. So it's a counter example. So as you can see here, I only instantiated the example. I gave it all the pins that I got from OpenFrame. So they are the same pins. And here in the example Verilog code itself, I have the modes. So the modes that we were just talking about: input, input pull down, input pull up, output, and bidirectional. I defined them here as local parameters. There's output as there's analog as well, which is 0, but because this example does not have output, or it doesn't use output, so I didn't define it. And then I just want to show you here how we actually configure an input IO. So I'm configuring here the GPIO 0 and 1 as input. So as you can see here, I'm putting 0 on output. Actually, this is not. Actually, let's look at the output. So I defined the parameter here, which is the mode output. And then I defined the counter output to be on the IO out. I left IO in and IO OEB empty. By the way, the only time you would need to use the IO OEB is when you are doing bidirectional. So if you're using input or output, you can leave it empty. And then I just give it the rest of the signals that I got from OpenFrame, and that would basically configure the GPIO for me. So actually, let's run a test. So we can do cf verify -- list, which is going basically to give me the list of verification test benches that I already wrote. So I can run one of them, or I can run all of them. So I will run all of them. Okay, cf verify all. So yeah, so this is going to run each test in sequence. So yeah, all the tests passed, and it gives me like a nice summary at the end. And we did clean up the output from CocoDB, so it actually looks better and easier for you to kind of debug and understand how the tests are working. And of course, a lot of that is having logging inside the test itself, because we're using Python, so we can add logging. And then the next step is to harden, right? So I want to harden my design. So I am going to look at the macros that I can harden. So as you can see here, I have the config GPIO GPIO config example, which is going to be my core design. And then I have the OpenFrame project wrapper, which is the top level, right? So what you want to do is actually to harden the macro first, if you're going to do the macro first option. We have three options. We have the macro first, we have the flatten on the top level, and the mixture of both. So you can have the macros and a top level that is flattened. In this case, we're doing macro first. So I'm going to do CF harden. It will detect if you're using Nix or Docker, so it does support both. And we're not gonna leave because I ran this before, so we can move ahead because this is gonna take a few minutes. So we can actually take a look at the final GDS that it created. Looks like I don't have the GDS here. Actually, I do. Layout GDS OpenFrame. Yeah, so this is basically the counter that you can see here. It's a very small design, so it's using small area. But this is the counter example, and this is how the wrapper looks like. So yeah, we can move ahead from here. And the final thing which is done locally is running pre-check. So pre-check will run a series of, oh, sorry, not in the pen. So pre-check is a checker that basically runs a series of checks. DRC, LVS, XOR check, which basically makes sure that your design can actually fit inside the template that you're using. So we do recommend that you run it locally before submitting to tape out, because you're gonna find that it catches all the issues that tape out might catch before even submitting. So it's a smaller a loop back so that you can fix the issues before actually submitting. And then we can also bin activate. Okay, so now if everything went well, if pre-check passed, and I'm confident with my design, I can then submit to the SFTP server. So I'm gonna do CF push. By the way, if you haven't already went through the credentials, so what you do is you create an SSH key through the CF tool as well, and then you submit a form to us, which will onboard you and send you back a username. And then you will be able to configure the SFTP server on your end using CF config. And once that's done, you'll be able to push it to our SFTP server. So this right now notified me on my email that I submitted something, and it notified Chip Foundry as well, so that we will run the tape out flow for you, and you will get the reports of the tape out back. So yeah, that's it for the live demo. So I'm gonna give it to Jeff to talk about production.
Super. Yeah, thanks, Marwan. So yeah, I wanted to talk. We're going to talk a little about our production solution. So at Chip Foundry, our aim is not only to make prototyping more accessible and affordable to a broader set of designers, but also lower the barriers for products with lower medium volume requirements. Our Chip Ignite production solution leverages pretty much the same model that we use for aggregating multiple customers for prototyping. So on our prototype shuttles that we run, we have a standardized reticle that accepts Caravelle or Caravelle size dies, and we aggregate up to 40 projects when we run a prototype. When we run a prototype reticle, so it's a full dedicated mask set that we generate for each time we run a prototype run. For production, we're going to basically redo the same thing. We're using the same standardized reticle, but instead of populating with 40 projects, we're populating it with multiple instances of customer projects based on their individual volume requirements. All right, so by basically adjusting the mix of the number of instances that we have on the reticle plus the number of wafers that we run, we're able to meet a kind of a range of different volume requirements for the combined set of customers for that particular fabrication run. Right, so the solution is really good for, again, more being able to serve more niche industrial or IoT applications as an example, or for products concepts that are maybe new and don't have an existing established volumes. It's also good for scenarios where you're extending the portfolio of existing product line where you may have some SKUs that don't have the volume requirements that would justify dedicated mask sets, and or wouldn't justify typically going to market, but you may be able to make more sense in the context of a shared leveraging a shared fabrication production run. So moving on to the next slide, Marwan. The model is basically based on the concept of an anchor tenant a customer model. So we have two types of customers, an anchor customer and a tenant customer project. The anchor customer projects basically typically have the highest volume requirement on the mask set. They are responsible for paying kind of the upfront NRE required to support the tooling to support that fabrication run. But they also get access to the kind of the lowest per unit costs for the actual production volume. And this is they also, in addition to that, they set the timing. So they define kind of when the tape out would occur. So they'll set that based on their needs or their requirements, and kind of with that, the timing for the fabrication run that precedes that. They also will get a rebate back as we are able to bring on additional customers to ride on that same shared production run. So those customers we call tenant customer projects, and those tenant customer projects basically get to get access to volume production, but they get to do so at a much lower upfront NRA. So a relatively small fraction of what the total tooling costs would typically be to do a production run. The whole solution is kind of on the base level. Base level offering is untested bare die. However, we are providing optional services for customers who need it, including testing and sorting die, so pre-testing die. We're going to be doing that predominantly through a kind of wafer level test. Again, leveraging standardization that exists in the in this solution with the common die pad frame. And then we also will support customized packaging based on the specific requirements. So that's all things that we would if you engage with us and reach out to us, we would set up a call and have a conversation, talk about your specific requirements, and then how we can meet those or best meet those. All right, so I think I covered the key points. So I think if you want to learn more, please check out that webpage. There's chipfoundry.io/production, or click on the QR code there. They'll take you directly to that page. You'll see a little bit more about what I just talked about. Also, there's a form there to reach out to us, and we can set up a call to have a conversation. Okay, so maybe moving on, Marwan.
Yeah,
All right.
I did.
So yeah, go ahead. Did you wanna jump on or cover this, or do you want me to?
No, I told you. I was just saying that I got you to the right slide.
Super. Thanks. All right. So we want to, just before we wrap things up, wanted to highlight a few recent and kind of upcoming highlights that are that we didn't cover explicitly so far. First of all, we have our May shuttle is open, 2605. Our full schedule is actually posted on the website, so you can under the Chip Ignite menu, you'll see a link for the schedule, the full schedule. If you've already running on an existing shuttle, you can find also status about the shuttle, our previous shuttles as well. But definitely encourage you to check out the next shuttle that we have open is in May for a May tape out. And we have two additional shuttles planned for later in the year, both in September and December. In addition to that, we've done some enhancements around our knowledge base. So we've replaced the previous knowledge base that we had with a new enhanced backend. And we are also expanding the content and a list of articles there to kind of provide more support and guidance around completing designs. And so check that out. That you can find that link under the resource menu on the Chip Foundry website. In addition to that, we've also launched a marketplace, and so you can see a little snapshot there on the right. But there's a marketplace that basically hosts a set of resources from including reference designs, IP blocks that you can use and incorporate into your design, information around tools that are available, as well as services and service providers that would be that you can also engage with for various requirements outside of our kind of standard solution or standard offering. So we're going to expect to be rapidly expanding, extending that here over the next several months. But you'll see, you can go out there today and kind of start to explore and see what's and track kind of what's coming. And then lastly, on kind of the recent announcements, we have just launched a design contest for submitting or for building a reference application. So this is we're really excited about this contest. It is basically time for fabrication on the May shuttle, and if you can check it out at the link. I believe it's actually you'll see a link directly on our homepage that could take you to more information around the contest itself. But what we're looking for is submissions for building a full application using Chip Ignite with the custom using Chip Ignite to kind of power that design with custom silicon. So please, if you're interested, check it out. Coming soon, kind of in the future, as I already mentioned, we're going to be expanding on the knowledge base and marketplace content. So that you'll see a lot more kind of coming here over the next number of weeks and months. We also have two new templates that are going to be announced or available this year. One of those is based on an ARM-based version of Caravelle, the Caravelle SoC. That project is called Swift. That design uses an M0 core in place of the RISC-V, and we're going to be providing that as an option for customers to be able to build designs with. We also have a next generation version of Caravelle that was in development previously through eFabless, and now we are continuing to we're completing that work and making that available for customers. That is going to feature higher performance SoC as well as support for analog and machine learning acceleration. So look for more information on that as we later this spring as we get that out and available for customers to start to use. Okay. I think with that, we can maybe move to the Q&A.
Yeah. So please write your questions in the Q&A feature on Zoom, and we'll be answering them live. So we do have a question. Will there be an option in the future to combine multiple tiles? Example, combine multiple open frames into larger area.
Yes. Oh, a larger area. Okay. So what we do have is we are working on some templates to help and make it easier for you to share a single tile across multiple smaller designs. So taking a full open frame and making that available in like either half a Caravelle size die or half die size or a third die size. So those are templates that we're actually pretty close to making available and publishing. In terms of and then we also have another project called Mini, which is a a project where that it basically allows you multiple user projects inside of a inside of the Caravelle SOC and kind of basically provide a way to mux which project is currently active and running, right? So those are all kind of ways to kind of subdivide or and share, let's say a tile across multiple projects. Um, the in terms of aggregating to larger sizes, we don't currently have anything in plan that would, something we have to look at. We've had that request before. It just takes some consideration as we think about kind of our overall process and how and what that impact that has in terms of our ability to just kind of standardize the processing and placement and the model that we have with the Foundry and the OSAP providers in the back end. But that is not something I have immediately. I don't think we have any immediate plans so far for that, for a larger size area. Okay.
Yep. So the next question is actually two questions. So do you have any pricing details for reference? And will the production timetable be aligned with the shuttles?
There's a little bit of pricing reference in terms of production pricing. I can tell you a little bit about the generally the best thing is to reach out to us and set up a call and we kind of have an open conversation around that. A little more open conversation on specifically based on your requirements, but at a high level, the NRE costs are on the order of a couple hundred K for an anchor customer and probably tens of K for um, a tenant customer to get access to a production run. And then the unit costs, I can tell you, like the anchor customers, we kind of show on the site like something sub $5, but it really depends on other requirements that you have and obviously your volume. So that will there'll be a curve based on the number of parts or units you need in production. And then as an anchor customer, then there's a kind of further reduction or cost per unit that you would typically see. And then in terms, well, the timing production time. So the timeline for the production is going to really be dependent on the anchor customer and their requirements, and that can really happen at any time. We just need to coordinate that with the customer who's kind of providing is serving as the anchor customer for that production run, as well as kind of making sure we align that with the Foundry and their availability to run the production or to do the production run. But we'll basically set time with that customer, with the anchor customer, define kind of a proposed schedule. We'll kind of confirm that with the Foundry, and then we'll make that known to other customers who want to potentially join or participate, and with an idea that we can try to get as many tenant customers on board as well to help mitigate the costs for the anchor customer.
Yeah, great.
Right.
Yeah. Are you planning to offer different technologies like IHP?
Currently, that is something we're continuing to look at in terms of, and we have been asked that quite a bit, and we have, we've had a number of conversations around that. We're continuing to evaluate what we can do and when. Part of what makes a model work is having critical mass right around an ecosystem around a particular technology node. So it includes having enough customers and demand to be able to make the shuttles work, as well as having the IP and the tooling and all the and the SOC templates and everything that we need to kind of be able to support a new node. So that's all the things that we're kind of considering and thinking through as we move forward. But we're definitely that question is actively being evaluated, and we are and we have had some kind of conversations with a number of different potential Foundry partners.
Yeah, good.
All right.
So what can be the max style area if we combine many templates?
So right now the current max area is defined by the OpenFrame template area. So I don't know if Marwan, if you have that handy, but it's
15 millimeters squared.
15 millimeters, right?
That's the core area, not the die area.
Yeah. So that's the core area, and today we require some sort of a frame to be able to support the flow, the process, the production flow that we have today. So the largest area is going to be really based on that OpenFrame template today.
Okay.
Yep.
So the next question is, does the new CF workflow leverage OpenLane or the newer Libra lane? So I can answer that. It is leveraging Libra lane. So OpenLane 2 and Libra lane are now aliases of each other. So it is leveraging the latest flow. Do you also consider timing performance of these designs in pre-checks? We do have an STA flow. It's called timing scripts. You can run them on your design, but they are not part of pre-check. So pre-check only does the physical verification of your design. It doesn't do any functional or timing verification.
You should also note that there is timing, obviously, as part of the PNR flow when you harden and you run OpenLane, and there's more detail that you can provide around evaluating and reviewing those timing reports. But in addition to that, there's static timing analysis that can be performed on a full chip level with integrated, with Caravel integrated, and that's what Marwan was just referring to.
Mhm. Yep. Okay, so for the next question, for a small commercial batch, the 10 to 100K should be the same project or design?
You So several answers to that question. So for individual die, so the solution allows you to kind of submit a project die just like you do for on an MPW, and run that at volume, starting anywhere around 10K to up to 100K, and that would be, that's the same project running at that volume. You can obviously combine. You can actually do multiple different dies to get uh, different variants, I guess. But they would be separate projects and separate slots typically. The other thing that we are doing is we're providing a subdivided die area solution where you can take the full area of a Caravel and basically divide it into 2 or 3, and then those instances can be the same die or they could be mixed. You could have different core areas in each of those dies. And that's really up to you, whatever you submit, as long as that passes that passes pre-check, passes our design verification, then yeah, we can manufacture that. So hopefully that answers the question. But if you have a follow up on that, let me know. Let us know if I didn't quite clearly cover it.
Okay, so next question. What will be the user area for the two new templates, same as Caravel?
They have they'll be a little bit different but similar. Yeah, I think the Frigate has a slightly smaller area. I think it depends on whether or not you have the analog. There's an analog subsystem block in Frigate that you can choose to include or not include. And that kind of changes the total amount of area. But with the analog block included, that consumes some of the user project area space, and you end up with a little bit smaller area than a standard Caravel. On the Swift, I think it's pretty similar if I remember right, but I don't remember the specific number.
Yeah.
But they would be different user project wrappers. They're going to have different interfaces. The Frigate they both actually use an HB bus in place of the Wishbone bus. So they're going to have a different bus interface that extends into the user area.
Yep. Great. Okay. Okay, so next question, does the CF GPIO config soft IP have the capability to handle dynamic GPIO configuration, or is it only for static configurations? So no, it's only for static configurations. We can't do dynamic configuration unless there's some sort of processor that you can write firmware to. So yeah, so it's only for static configuration for now.
Yeah, design time config. So, but you, of course, you could implement, if you don't, not using that IP, using, rebuilding your own logic, you could of course implement some sort of runtime configurable programming to the IOs, but you'd have to understand those IOs and how they're configured and implement the logic in order to be able to support that.
Yep. Okay. So next question. Would you provide the download link for the recorded webinar?
We're posting on YouTube. That's how we make these available. I don't think we're gonna probably likely provide downloadable versions of the webinar. If you have a specific need or interest for that, let us know or reach out to us, and we can talk about it. But generally, we provide the way we publish the recordings is through YouTube, and so that's what we'll provide that link out after the webinar.
Right. Okay. Is there plans to make pre-check on cloud again, like what eFabless had?
We're looking at it. Yes, we are working at a way to be able to run pre-check and potentially other um, processes on a back end on our back end as part of the design flow process as an option.
Okay. Okay, next question. Are there other working OpenFrame examples that can be referenced? I see the current example doesn't have LVS enabled. So if you can send me the issue on email on why the LVS is not enabled, it should be enabled. This example that I was just showing is going to be it's actually right now on GitHub. There's another timer example, and there is a Pico RV example. So there are 3 examples on our GitHub organization. But about the LVS issue, please do send me an email, and I'll take a look at it. Okay, so last question, basically asking about information for Frigate and Swift,
Yeah.
how to get the information.
So we're going to be posting more information. So Frigate today is we have kind of a first iteration of Silicon that we're testing and validating functionality. We do have an initial preliminary GitHub repo that is available on the Chip Foundry organization. If you look up your search for Frigate, you'll find both Frigate and the Frigate user project that's out there. But that's all kind of early right now, as we're still kind of working through getting that ready for use. And then the Swift is not. We'll still have to. We're still working through. Basically, that design has already been validated and everything is good. The biggest question we're working on getting basically set up with ARM to be able to support that, and we already have that now in place. The last step for us on that is we need to review the design and abstract some of the ARM IP and any ARM IP that we can't make available publicly. So we're going to be basically black boxing some of the design flow process to make it so that we can make it available for people to use and design and submit with, but still protects the IP that needs to be remain not publicly available. So that's the last step we have to do for Swift, and that should be available and out shortly.
Okay.
All right.
So if you have any more questions, please do submit them because that was the last one.
All right.
Okay. Yeah. It's good.
So thanks everyone for joining the webinar. I think with that we probably can wrap it up. Look forward to, you can look for an email out from us for everyone who registered with the links to the file, to the slides, and to the recording here, either later today or tomorrow. That should be available. And with that, thank you again for attending, and look forward to seeing or hearing from you. And please reach out to us if you have any other additional questions or interest on anything we covered. Thanks.
Yep. Thank you all. See you.